going to do a demo here of how the Bootstrap program works within the J8CM. I've also got my new memory viewer. I just wrote this, and this will allow us to look into memory without having to switch screens within the J8CM itself. The J8CM writes a snapshot file out to disk, and this memory viewer then will view the snapshot as it. I have to refresh it. I'd like it to be more dynamic, but baby steps. So the program that I'm going to load is over here on the right. I've got some data file or some data locations reserved, some bit patterns here, and a one that I'm going to shift across the accumulator. I've got a location reserved here for my output buffer as I'm going to store the contents of the accumulator and then store it into F and then write that to the output stream. So here I'll load X with a bit pattern, load Y with all ones. Then I'll load the accumulator with the one right here, store it into F, and then write the contents of that F out to the output stream. Then I'm going to start in a loop, and this instruction is an arithmetic shift left. So it will move that bit from bit 0, that 1 from bit 0 over to bit 1 and then bit 2. As we go through the loop, it'll keep moving that across the accumulator. I'll store it, write it to the output stream. And then I'm going to check the 0 flag in the processor status word. Once I've shifted that bit all the way till it falls off the end of the accumulator will go to all zeros, and that 0 bit will be set in the processor status word, and I'll jump out of the loop. I'll jump out of the loop and go to the halt, which is set at memory location 60. The JMP is the jump command. So I'll jump back to the loop label and increment, and that's how my loop's going to keep working. When I jump out, I'll go to the halt and load start in the program counter. The loader file for this program then looks like this. Again, it's decimal under the covers really with the J8CM. But we have the memory location, and then we read the contents of the memory location, and we go all the way through. And one thing the loader program does is it appends this 5 at the end, and I'll show you the significance of that when we look at memory and the Bootstrap program. So coming over here then, what do I have? Well, we can look in the memory viewer here. Oops, I keep pushing the wrong button over there. And we have all zeros in memory. You can see here that it's all zeros. So that this is a snapshot of this. And if I go into the data destruct, that's where I have the initialized Bootstrap. So I just press that real quick, and then if we come down here and we go through here and we go ahead and hit refresh, we can see that it wrote a couple of bytes of data into the um, bottom of memory, I guess. I don't know, zeros anyway, or starting at location 0. So what this does is all zeros, when that's read into the instruction register, that's a read command or an input command from the input stream, and it has an operand, and the operand is going to be this byte of data. And so what it's going to do, it's going to read this 10 from the input stream with this command, and this tells where to store that 10, and that is memory location 3, which is right here. So it'll take that 10, it'll store it here, and then it'll proceed, the program counter will increment, and we'll read this instruction, which is another read from the input stream, and it's going to read this 1, and it's going to look at this byte of data, which will have 10 in it, so it's going to store that 1 into memory location 10. Then it's going to go to this instruction, which is the jump instruction, and that's going to say jump to this location, which is back to 0, and then that's going to read the next byte of data, which by then will be this 11. It's going to store the 11 right here, and then it's the program counter will increment, and it'll read the 170, that bit pattern, and it'll store it in memory location 11. And then so it'll go through like that, loading all the memory locations. So it'll eventually get to, where it starts loading the main body of the program, and then the halts and all that good stuff. And then it's going to get to uh, this 5, and it's going to read that. It's going to read 5, and it's going to store that 5 right there, and then it's going to read the next byte of data, and it's going to store it in location 5. Well, the next byte of data is 30. It's the start location for a main block, and location 5 is right here. So when it gets to this jump instruction, instead of reading 0 and jumping back to here, it's going to read the 30, and it's going to jump forward into location 30. Is that 30? No, that's 30. It's going to jump into location 30, and it's going to take off and run the rest of the program. So I can prove it to you. Let's go to the main menu. Oops, got too many keyboards in front of me. I think I have. Let's look at the I/O panel. Yeah. All right. So I've got the program loaded into the I/O program, or the input stream. I did that when I loaded that .loader file. I might have done that before I started this, but that's all right. And I'm just going to run it real quick. So we've got all zeros in here. So I'll hit run. I've stepped through programs in the past and in other demos, but this one I'll just hit run. And it went through it very quickly. It got to our halt at the end. You see it loaded the X register with the pattern and the Y register with all ones. Now, let's go and look at the I/O panel. What the heck? And you can see then now we have our output, and it's these ones. So it loaded the accumulator and incremented, or shifted, did an arithmetic shift left, and shifted that all the way across the accumulator until the accumulator became all zeros, and that's when it would have jumped out of this loop over here. And if we look at the input stream, I can, let's say next block, and you can see that the input marker ran through to the end of the program that was loaded into the input stream. So we can go back here and look at, I got my viewer here, so let's just use that. Refresh this. And you can see where all the data has been populated. And in fact, it left that 5 at the end of the loader here, that 5 that it loaded there, and then the 30 that it loaded right here. And then when it came around to this jump, the jump read the 30, and it jumped down to location 30, which is right there. And I don't have my cheat sheet in front of me, but I'm pretty sure that's going to be that load X. And then it loaded it with, this bit pattern right here. And it went on through the rest of the program. So if I come back to the front panel and just clear it, I'll just step through a couple of them so you can see. If we clear that and we go back here, and let's go to data destruct and clear memory, yes, and then initialize our bootstrap. And so I go back here, go to the I/O panel, and if I go clear, I can clear the output stream, and I can hit this marker reset to move the marker back to the beginning of the input stream. And let's refresh our view of memory. And you can see I've just got that bootstrap in once again. So if I come back up here and go to the front panel, I'll just step through a few instructions, and then we'll look and see. I'm not going to go through the whole thing, but I'll just step through a few. And then if we come down here and refresh our view, you can see we've started to populate the memory with there's our 1, there's our bit pattern, and then in location 12 we got 255, kind of matching up. It'll correlate with what we have here. See, 10 has 1, 11 has the bit pattern, 12 has 255, and so on. And here's the start of our program. I can come back up and step through a few more and come back down here and refresh it. And it looks like a few more, I believe. 36. So that should give you an idea of how the Bootstrap works. Heck, I can probably come up here and just hit run and then come down here, and we can see that it's loaded the rest of the program, including the stuff down around 60. So that's how the Bootstrap works. The thing was one of those things that I was surprised at how simple the program ended up being once I worked long enough to simplify it that much. Hope you found it interesting, and thanks for watching.